Now that we've completed the A and B transformations, we're moving on to C. The constant C is translating my graph horizontally, and the only thing you really have to remember is that the graph's going to move the opposite way of what the sign says. So if your equation is x plus any number, like x plus 3, then your graph moves left. If your equation is x minus c, then your graph moves right. Now, it's really important that the C value is going to affect the scale you use as well as the B value. So you want to make sure, like if you're trying to pick your own scale, if you're doing some of the questions that are in the homework, like in the textbook later, if you have a period of pi by 3 and you're doing a phase shift, so you're moving, let's say, left pi by 2, then you have to pick a scale that's compatible with both those numbers. So what you want to think is lowest common denominator. If you make your scale pi by 6, then you're good. Now, just a heads up, on your test, I will tell you what scale to use so you don't have to think of this. This is only if you're doing some extra practice in the textbook and they didn't give you a grid and you're like, I don't know what scale to use. The easiest way to pick a scale is make something that's compatible with your phase shift in your period. And so if you just make a lowest common denominator, it will always work. But here we go. So what I want to do is I want to graph y equals the cos of x plus pi by 3. So the first thing we're going to do, as always, is go to Desmos. So I want to graph y equals the cos of x. And then I'm going to graph y equals the cos of x plus pi by 3. Okay. What do you notice? Well, the black graph is my y equals cos x graph, and the blue graph is my y equals cos of x plus pi by 3 graph. Let's just take a second on the black graph. The black graph is y equals cos x. It has a period of 2 pi, which means that my key points are happening every pi by 2. My blue graph also has a period of 2 pi, and so my key points are also going to happen every pi by 2. Now you can see here I don't have a great scale because my scale here is what? Like from 0 to pi by 4. I think my scale is like pi by 16. And pi by 16 doesn't really work with a phase shift of pi by 3. So I'm going to go in and do what I recommended. So I said that when you're finding a scale, what you want to do is pick a lowest common denominator. So we know that my key points are going to happen every pi by 2. And I have a phase shift of pi by 3. So I'm going to make my scale pi by 6. Pi by 6. Okay, so now let's look at this. So did it do it? What did it make my scale? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I didn't do it. Sometimes I don't understand what Desmos does. What if I go pi by 3? 1, 2. How many does it take? 1, 2, 3, 4, 8, 12. Oh, there we go. Random. Okay, now it's got a scale of pi by 12. So now what I want you to see, all I want you to see from this is, and I'll give you better scales, but what I want you to see is that this blue graph is my black graph moved left pi by 3. So I've found a scale that gave me pi by 3 in there and I've moved it. And then my key points are going to happen every pi by 2. And so how many grid lines is pi by 2? Well, if you look at this, pi by 2 is right there. So it's 1, 2, 3, 4, 5, 6 grid lines. So from this starting point, I'm just going to go 6 grid lines. And then I get to my next key point. And then 6 grid lines, and I get to my next key point. The tricky thing here is that I'm not starting at 0. I'm starting at x is negative pi by 3, and then I'm putting a key point every pi by 2. And so it's just a tricky thing with scale. So now let's look at the example that I gave in the notes. So we've got y equals cos of x plus pi by 3. Let's first off look at what scale I've given you here. I don't know why PDF made some of this black, but that's okay. So I've set the scale at 1, 2, 3, 4, 5, 6. So I set the scale at pi by 6, and I did that on purpose. The amplitude of this graph, the a value is 1, so the amplitude is 1. The b value is 1, so my period is 2 pi. My key points are going to be 2 pi divided by 4, or every pi by 2. And let's figure out how many grid lines pi by 2 is. Now to figure it out, you could figure out where pi by 2 is. You could go, okay, it's halfway to pi, so it's 3 grid lines. Or like they were showing me this morning, you could do pi by 2 divided by pi by 6, and then you could flip and multiply. And then you can see that you're left with 3 grid lines, right? Whatever makes more sense to you. And then I've added this category here of phase shift. So we're going left pi by 3. Now, pi by 3 is how many grid lines? Well, pi by 3 is a third of the way to pi, which is going to be 2 grid lines. And again, if you want to figure that out, you could just do pi by 3 divided by pi by 6. And again, flip and multiply, and you'll get 2 grid lines. The domain is going to be negative infinity to infinity, and the range is going to be negative 1 to 1. So how am I going to graph this? Well, now I'm going to pay attention to the fact that this is a cosine graph. So cosine graphs normally start at 0, 1, but I'm going to take that point and I'm going to shift it left 2 grid lines. So it's going to start here. This is negative pi by 3. So I've gone left pi by 3, which was 2 grid lines. Now I don't care. Now what I care about is that my key points are going to happen every pi by 2, which is 3 grid lines. So every 3 grid lines I'm going to do another key point. So 1, 2, 3, down to 0. 1, 2, 3, down to negative 1. 1, 2, 3, back up to 0. 1, 2, 3, up to 1. 1, 2, 3, down to 0. 1, 2, 3, down to negative 1. And then I'm going to connect my dots. So I'm going to start on the right. And that's y equals cos of x plus pi by 3. So again, a phase shift, you have to figure out where you're starting, and then you got to look at your key points. So from there, every 3 grid lines I did another key point, and that gives me, so what you want to check is that my cycle is still 2 pi. So from peak to peak, actually let's go maybe from here. So this is at a point pi by 6, and then this point here is 2 pi by 6 plus pi by 6, right? So it's pi by 6 past 2 pi, which means that my period is 2 pi, and it worked. Okay, so that is your phase shift. So you got to figure out where you're starting and then just do that regular cycle from there. So here's one for you to try. So I want you to try y equals sine of x minus pi by 4. Figure out the scale of this grid, see if you can go from there. Pause the video. Okay, so what is the scale? 1, 2, 3, 4, 5, 6, 7, 8. So my scale is pi by 8. The amplitude is 1. The period is 2 pi. Key points will be every pi by 2. Now pi by 2 in this scale is halfway to pi, so it's going to be 4 grid lines, or pi by 2 divided by pi by 8 gives you 4. My phase shift is going to be right this time. I'm going to go right pi by 4. And I got to figure out how many grid lines. So a quarter of the way to pi is going to make it 2 grid lines, or you do pi by 4 divided by pi by 8, right? Divided by the scale, and that'll give you the 2 as well. So even here for the grid lines here, you could do pi by 2 divided by pi by 8, right? That's how you could figure out how many grid lines it's worth. Domain is going to be negative infinity to infinity. Range is going to be negative 1 to 1. Okay, so what am I going to do? Well, a sine graph starts at 0, 0. But now I'm going to move it right 2 grid lines, so it's going to start here. Now, every 4 grid lines, I'm going to have a key point. So 1, 2, 3, 4, up to 1. 1, 2, 3, 4, down to 0. 1, 2, 3, 4, down to negative 1. And 1, 2, 3, 4, back up to 0. Check your period. It started 2 grid lines after 0. It ended 2 grid lines after 2 pi. The period is 2 pi. I'm good. So now I'm going to go again to the left. So 1, 2, 3, 4 grid lines down to negative 1. 1, 2, 3, 4 grid lines up to 0. And then I'm going to connect my dots. And I just had this point, like this question. I was like, oh, could you check a point? Could you plug in x, like this point here, which is x is pi by 2 pi by 8, so pi by 4. So could you plug in pi by 4 into here and check that you get a y value of 0, right? So you could check a point to make sure that your graph is good. But if you do this right, so if you do the cycle right, you figure out where to start, and then you know where your key points are going to come, then it should be all right. So which of the following characteristics does a phase shift affect? Did it affect amplitude? Nope. Did it affect period? Nope. Domain? Nope. Range? Nope. X-intercepts? Yeah. I mean, that's kind of the moral of the story. Everything affects x-intercepts almost, and it doesn't affect where your center line is. So now you're on to the next part of the worksheet, which is part 1, worksheet number 1 to 4. So just look for the ones that have phase shifts.